Hello, in this video I just wanted to clear some basic concepts on PDD and TMR. PDD is percentage depth dose and TMR is tissue maximum ratio. So before that, let us know what is SSD and SAD technique. If you consider this as the source and this as the isocenter, this will be 100 centimeter for LINAC. Um, so if this is the surface, this will be source to surface distance. If you consider this as the phantom, now if I keep the phantom like this, and this if you consider as the dosimeter, and if I keep the dosimeter over here on the surface and measure the dose, that would be source to surface distance. Now if I move the phantom inside, up, then the isocenter is lying in the phantom, but the source to surface source to this distance would be source to axis distance, that is again 100 centimeter. I hope the difference between source to surface distance and source to axis distance is clear. Now let us move to PDD and TMR. Before that, let us clear one concept, that PDD is measured in non-isocentric scenarios, that is SSD technique, and TMR is measured in isocentric scenarios, that is SAD technique. Now, the definition of PDD: the PDD is the ratio of dose at a given depth to maximum dose. So, this would be the formula: dose at a depth D divided by dose at a depth D max. Now, again, the scenario is source to surface distance. Okay, in SSD cases. Now I'll keep the phantom at the surface because PDD is measured in non-isocentric scenarios, that is SSD setup, right? So we have a SSD setup. Now we know the Dmax in for 6 MB Dmax is 1.5, right? So we'll take that as an example. So at 1.5 centimeter, if this is at the surface, right? At 1.5 centimeter depth, if I measure the dose over here, it would be dose at Dmax, right? At the depth Dmax. Now, if there is an unknown depth, that depth will be small d. So, dose at a depth d. Now, you see that I'm not moving the phantom. I'm just moving the dosimeter with respect to the surface. So, surface to source to surface distance is same. I have measured the dose at the Dmax and I have measured the dose at a depth d. So that ratio is PDD. PDD is dose at a depth D divided by dose at a depth D max in SSD setup. Now coming to TMR. TMR is tissue maximum ratio. Um, Tissue maximum ratio um, is the ratio at a given point and depth in the phantom to the dose at the same point at the depth of the maximum dose in the phantom. Now this is in SAD technique. Now let's see what happens here. So uh, now if I move the phantom like this, now it becomes SAD technique, right? The SSD technique is no more there. Now it is SAD technique. Now I'll measure the dose here at the Dmax. Okay. Now SAD technique, I'm measuring the dose at the Dmax. Now I'll move the phantom. In the previous case, I didn't move the phantom. In this case, I'll move the phantom here. So the SSD is moved closer, and now I'm measuring the dose over here at a depth D. So that ratio will be TMR. So TMR is uh, is the ratio of dose at a given point and depth in phantom to dose at the same point. See, I will not move the I'll not move the dosimeter also. So this is SAD technique. I'm keeping the dosimeter here and I'm just moving the phantom above. So at the same point, I'm measuring the dose. That is in TMR scenario. I'll read it again. TMR is the ratio of dose at a given point and depth in the phantom to the dose at the same point at the depth of the maximum dose in the phantom. So that will be TMR. Dose at a depth D to dose at a depth of Dmax in SAD scenario. That will be TMR. I hope that is clear.